This video shows you a normal start procedure of the magnet marker. The first thing we're going to do, turn on a PC. Launch the WaveRunner marking application by clicking the WaveRunner on the bottom left. Next, we make it full screen and we have to open the job. And we select magnet marker. The job is now uploaded. Next, we have to resize the panel for the right side of the screen by click and dragging to the right. Now, what we have to do is turn on the preview mode under Window, and we have the operator panel. Next, we click this little marker icon to launch the marker dialog. Here's where we can start and stop. Next, we're going to launch the Nexus portal to talk to the internet peripheral camera. Give it a second to pull the data. Now we see there's our camera. We select the camera and we launch the iDisplay. We give it a moment to establish the communications through the RJ45. Now we want to resize this panel to fill the left side of the screen. So we click, drag to the left, let go, and we have two panels. Click the manual trigger and we force a trigger. There we go. The camera is running. So with the WaveRunner, we must click the start mark F2, not the green button, for the first cycle. So we click the start mark. Now it's running. It samples the part which has been pre-installed properly. Now you can see, for the sake of this video, we're doing manual triggers to watch it mark. Normally this is unnecessary, but we can see the laser's marking, and we'll let it finish both of the serial text marks, and then the last marking process is a 2D code in the top field. So it's marking the 2D code now. When it's done marking, the WaveRunner will tell the camera to read the 2D barcode, and the camera will either give it a code fail or pass the green number, which it did in this case. So we have a good part. The door remains unlocked. We can remove the part and install another one. At this point, we can press the green cycle start button for every part we install. So long as the part is installed correctly, we can let them process, the door will close accordingly, and we're manufacturing volumes of parts. It's important to realize when you're inserting the workpiece into the magnet marker system, you must put in a proper piece that's ready to be marked. This piece was marked from a previous cycle. The software says it's upside down, so the operator has no choice but to pull that part out, open the door, and he's supposed to put another one back in. So what we're going to do is pull it out. Now you'll see it still says upside down. Code will not allow itself to proceed with marking. So now the operator must open the door again if it's not open and put a part in the way it's supposed to be. Set up a workpiece. So he puts the workpiece in. But here we put the workpiece in upside down and it has the Abbott logo. Again, the software is smart enough to realize that it's not a proper part ready to mark. So it's reporting upside down and it refuses to continue to pass the handshake to the laser to start marking. So only if we put in a proper blank piece for the magnet marker to continue. Here we place a blank piece in. It's now green and it says print 2D. And the machine starts to mark the code. And we'll watch that for the sake of this video. And once it's done, it'll read the engraved, marked 2D code is now in process. It takes a few seconds before it's complete. Once it's complete, the marking system will bring that to the attention of the master PLC, and it tells the camera to scan it, and you'll see we have a passing part once again. Now, the other condition is if we do open the door and pull that part out, we could put in a blank or a mismarked piece. And the question is, what happens when the mark has been printed incorrectly? So here you'll see we have an incorrectly marked two-dimensional code. See here, this is a mismarked part, and with a Sharpie pen we colored in the 2D code. But the software reads right away and it shows red font and it says code fail. This is a special case. We terminate the usage of the system. The magnet marker is now unable to be operated until the supervisor is called over with a key. Only with the key can he open the door. The door has now been locked and latched. Once the key is installed, he can open the door, take the bad part out, bring it to the attention of management, and find out why the part has failed. Periodically for the magnetic marker, we have to change the lot code. So the first thing we have to do is turn off the mark function by clicking the X. Next we have to switch to the main engineer editor mode for WaveRunner. So first we're going to change the actual text by selecting the green icon, and we will now search text 2D. Inside we change the code to the desired number. In this case, we're changing to the number of 57. And then we apply. Next, we must select the icon for the 2D code in blue. We click the barcode tab to engage the tool. And here we must also change update the lot code. So we change it from 55 to 57. Apply. Now we're ready to change the WaveRunner back to the operator mode, which is preview or F9. And we can launch the mark dialog. Next, we have to change the code in the camera. So first, now we're going to run a part by clicking Start Mark F2. We manually trigger the camera to bring it back on, and we let the machine mark the part. We'll see it's marking here. We're actually manually clicking triggers just so the sake of this video we can see the part being marked. It takes a few seconds to actually mark a part, maybe 15 seconds. Once done, the inspection status will change. It says code fail, which is correct. We have not yet updated the lot code. To fix this, we must close iDisplay, select our camera in the Nexus Manager. We find in the Nexus Manager, we launch our camera editor by clicking the green Connect button. Next, we have to find the third icon in blue, which is the Tool Editor. We click on it to launch it. Therein, we need to change the lot number in the perfect edit box. For this example, we enter the digit 7 at the end. We click Elsewhere to change the lot number. Next, we relocate the search field to ensure the 2D barcode is in the center. The left green trigger. The camera gets refreshed with a new picture. We notice the data has been updated when the LED turns red, as expected. We again enter the digit 7 in the perfect field and realign the search field. We again enter, the LED turns green when the camera has been updated. We will see the perfect code matches the interpreted code. When the code matches the 2D barcode, we can move forward. Next, we close the camera editor. Click OK to save. Select iDisplay in the Nexus dialog. We select the camera first, then click iDisplay. As soon as iDisplay launches, we grab the header and slide it to the left so Windows repositions the running applications side by side. We click WaveRunner to bring it to the front, and we are ready to run. First, we have to click Start Mark in the graphical user interface. After clicking Start Mark, we will click the green play button. The icon goes from a green arrow to red. We see the camera is marking the part. For the sake of this video, we click the trigger button to update the image as it marks the part. We see the bright light is the marking process, and finally we see the camera confirms the part as passing by displaying the interpreted 2D code in the inspection status window and the code inside image with green font. We have successfully printed the desired 2D code on the part. The following procedure is the instruction to establish a history of laser power output. The data is logged on the side and kept long term. First, we have to set up the power meter and install it under the laser beam. We have to turn on the laser, ensure that the key is in the on position, locate the power meter inside the protected system by opening the door and installing the actual power meter under the laser gimbal output. Once the meter is on, we set it to automatic power meter mode to sense the proper power. We are going to be looking for some order of watts. In order to start the power output procedure, first we are going to close the marker dialog. Next, we select Window, and under Window, we select the Main feature to go back to engineering edit mode. From here, we click the tab Mark if it's not already selected. Next, we click the default red pen, and we see here it's set at 40 watts. Next, we have to click the Advanced button, and then we click Power Map. Therein, we look for several points of interest. In our case, we recommend 16 watts, but 24 and 40 are also acceptable. See here, those are the other points. We'll make a record of that to establish a history. Next, we see the bit value. We must enter the bit value down below in the text edit field, 1632 in this example for 16 watts. Next, we have to turn the laser on by clicking the laser on button. We watch the power meter, give it 10 seconds for the power level to settle. At this point, we make a record of the power measured. We repeat this procedure regularly several times a week for each of the required power wattage levels. We cancel from this dialog and we are done. We then select Preview to reconfigure the WaveRunner back to operator mode. And then we can click the Mark icon to invoke the Mark dialog box, and we are prepared to continue manufacturing parts.